Hello, and today we're going to be looking at linear programming. So, linear programming is where you have a graph with multiple inequalities, in this case linear, in such a way that we can use them to calculate either profit or cost, depending on the circumstance and the inequalities. So what I've drawn here are three inequalities, undefined, but I can tell you already that it's probably going to have something to do with profit. Well, okay, that's great. Let's actually dive deeper a little bit more. So, first thing that we have are the constraints. This is where all the inequalities are going to be. So, if this was our graph here, there's a couple constraints that are given automatically. We don't like dealing with negative numbers when we linear program, because why would you have negative profit when you can just have cost and make that positive? So it just doesn't make sense. So we make sure that x is greater than or equal to 0 and y is greater than or equal to 0. So if we were to sketch this on our graph, get a slightly different color, underline them, it would be here, like so. And then instead of doing like we normally would, getting the region required and shading the area that is required, we're going to do the opposite. So when we write our key, it's going to be slightly different. And instead of region required, we're going to have a feasible region, or FR for short. So our feasible region is going to be everything that's left blank. So all of this space here that doesn't solve the equation is going to get colored in, like so. Okay, that's great. Now we have this entire quadrant to ourselves. This is the feasible region that we're after. Well, it doesn't exactly make sense at the moment because it has no borders. It will go on for infinity, which can be useful, but not for this video. We're going to be looking at profit, and we can't just have infinite profit. There has to be some sort of constraint. So imagine that you worked for a paint company, and there were two types of paints, paint type X and paint type Y, and there was a maximum amount of paint that you could ship in a week, for example. Well, then we can say that whatever X plus Y has to be some sort of amount. So let's say we can ship 100 per week. Let's say that was our constraint. So if we can only ship 100 a week, how much should we sell of both type X and type Y paint to maximize profit for that week? Well, that depends. How much does paint X and paint Y cost? Well, this is where another thing comes into play, the objective function. But first, let's plot this constraint here. So X plus Y has to be smaller than or equal to 100. So let's say that this here is 100 and this here is 100, and we'll plot it in a different color, underline, to make sure that you know what I'm talking about. And of course, you always rule your lines. Alright. And now you can do the check. Well, what is less than 100? It's going to be where the origin is. 0, 0. 0 plus 0 is less than 100. So this area here is what we want. So we shade the area that we don't want. Alright. So now we're left with this bit here as the feasible region. So I'm going to remove my key just so I can have some space, but you would keep the key there. Alright, so now we have something called the objective function. And the objective function is what you're trying to maximize or minimize. So in this case, we want to maximize profit. So we let P equal, and then how much X and Y, how much the consumer has to pay for X and Y type paint. So let's say X paint, type X paint costs $10, so we have 10X plus, and let's say Y costs $15, so we have 15Y. Alright, that's great. We now have our objective function, but we haven't specified what we want to do with this objective function. Do we want to maximize? Do we want to minimize? If we minimize, we want to make sure that we earned absolutely as little money as we possibly could. But of course, this is profit. So why would you want to minimize your profit? You will want to maximize your profit. So if we're maximizing our profit, how does that work? So here we have 10 and 15 as our two coefficients here. So we want to sketch a line on this graph, and we want to find out where this line here makes profit the highest possible within the feasible region. Now there's two ways to do this. This first way I'm going to demonstrate only is useful to understand the concept. Alright, so imagine this was our line here, and I could slide it as much as I want. We have, it's actually going to be something more like that. Oh, no, like that. So this was our line. This ruler here, this ruler edge here. So if this was our line, where can I place it in order to maximize our profit? Well, I could play around with the profit variables, or I could just visualize. So here it's telling me that if I want to maximize my profit, I want to make sure that I get 100y and 0x. So if we want to maximize profit, just by looking at it by eye, this should be, our maximum will be 100x, making 100y, making $150,000. Okay, what if we can't do it with by eye? What if we weren't given a graph, or we just don't have time to make a graph, and we want simple, quick, effective, and no room for error? Well, there is a mathematical way to prove it. So I'm going to remove my graph to make space, but keep that graph in mind. So on that graph, we had a triangle that was our feasible region. Here's our y, here's our x. We also know that these two sides were the same, and we know that it was a right angle. We don't know what this is, but we don't need to. So, I'm going to label these points of the triangle A, B, and C. And now I will say that I will make a table point, and then I will put my A, B, and C as a label, and then I will write down what point A is. So A, looking back at the graph, was the origin, 0, 0. And B was the y-intercept of this constraint here. So that was 100, 0, 100. And according to what we saw beforehand, this should be our maximum. So, and then point C was the x-intercept, which was 100, 0. So in this column here, we're going to have profit. So all we have to do here is sub in the x, y points here into our objective function to work out how much profit we would get at these points here if our line went through them. So if we were at 0, 0, we would have no money, none at all, no profit. If we were at point B, well, we would have 100y, so we would have 15 times 100, $150. And if we were at point C, our line would go through point C, then we would have 100x and 0y. So 10 times 100, and we're going to get 1,000. So without using the sliding method, we could see that if we wanted to maximize our profit, we would have to sell 100 of the Y-type paint. Now what if I change the cost of my Y-type paint to $10 instead of 15? Well, now we have a different problem altogether. We still have this triangle, but our profit has changed for B and C. So now they're both going to be $1,000 each. So if we were to maximize our profit, we would just have to make sure that we sell as much as possible. So we would write, therefore, our maximum profit is $1,000. Everything on the line between B, C will give us the maximum profit. So if this was 50-50, that'll give us maximum profit. If we got all 100 of type X paint, we would get maximum profit. All we have to do is that we make sure that we sell all 100 of the paint that we sell. So that's all I have time for today for linear programming. In the next video, we'll be covering over costs and how to minimize using the objective function. So I will see you in the next video.